Okay, we're going to do the split screen method for problem set 3 here. This is Dr. Hands, and we're going to go over the answers and solutions for problem set number 3. Once again, clear your calculator registers and make sure you're on one payment per year, and also your calculator is set in end mode. And let me get in pen mode, and we'll take a look at the first problem here and go through them one by one. Now, first one, okay, it looks like we're going to be calculating some mortgage payments. So I'm going to write number 1, and this has to do with mortgage payments. Some good practice on mortgage payments. We're all going to be experts in this. And Ted and Jane are buying a house for $280,000, and they will make a 25% down payment. So the first thing to do here is consider the mortgage amount, or calculate the mortgage amount. So the mortgage amount is 75% of $280,000, or $210,000. So let's write that right away so we don't get tricked and use $280,000 as our mortgage amount. So the Ted and Jane are putting in $70,000 and they're borrowing $210,000. They'll be able to obtain a loan at 8.5% per annum interest. What will be their annual payments if their loan is for 15 and 25 years? And then what are the monthly payments if the loan is 15 and 30 years? So the first step here, we're going to be looking at annual payments for 15 and 25 years. So I'm going to set up our time value of money menu. Make sure future value is empty and clear. N is 15 for the 15-year annual mortgage payment. The interest rate is 8.5, and that's percent. Now N and I are in the same units, okay, years and years, so we're in good shape there. And the PV is 210,000. I'll leave that as a positive, representing money coming in or cash flow in. And you compute the mortgage payment, and that should be negative 25,288 and 30 cents. Okay. Well, what I could do here for the 25 annual payments mortgage is I can just erase N, okay, and erase my mortgage payment. And on your calculator, obviously you're not erasing, but you're clearing the register and inputting new items there. So I just change N to 25 on my calculator. Make sure the interest rate is still 8.5 and the PV is 210,000. Then recompute PMT, and you should get negative 20,519 and 45 cents. Okay? So that was for 15 years and 25 years annual payments. The second half of the question asks for monthly payments for 15 years and 30 years. So let's change this around. And we're dealing with monthly payments right now. And the first one would be for 15 years. So 15 times 12, that gives us an N of 180. The interest rate is 8.5 divided by 12 this time. So divide by 12 and hit enter directly into the interest rate register. Again, I'm assuming that our calculators are set on one payment per year. So it's going to be a monthly interest rate of 0.7083% roughly. The PV is still 210,000. You compute your mortgage payment this time, and our monthly mortgage payment is negative $2,067.95. Okay, well, let's erase a few things here. Let's erase the payment. Let's erase the 15. Let's erase N. And this time we're dealing with a 30-year mortgage with monthly payments, or 360 periods or payments in total. Make sure I still has 8.5 divided by 12, and the PV is still 210,000. Compute your payment again, and this time your payment is negative $1,614.72, I believe. Okay? All right, I think we answered that. So let's move on here, and let's look at question number 2. So I need to scroll down a bit. Okay, number 2, we have $5,000 to invest, and it will be placed today in an account earning 7% per annum interest. If you add $3,000 to the account at the end of the 5th year, how much will you have on deposit at the end of the 10th year? So this is a future value problem, right? We're trying to calculate a value at the end of the 10th year. And how I'm going to approach this problem is really as 2 future value problems. We really have 2 things going on here. And you can treat it like 2 separate problems and then add the 2 components or the 2 problems back together to get the answer to the question as a whole. So this is a future value of a lump sum problem, or 2 future values of lump sum problems. Okay, the future value of $5,000 in an account earning 7% for 10 years, and then the future value of $3,000 placed in an account for 5 years. And we want to know what we'll have total from both those investments or deposits at the end of the 10th year. So let's set this up. Okay, I'm going to raise that a little. And let's see, can we scroll down? No, we can't. I'm gonna erase. And again, while I'm doing this, you can clear your calculator registers. Again, we're assuming 1 payment per year. We're in end mode, END. And there we go. Now we're ready. So this is problem number 2. Put my future value back in there, because that's actually most important, because that's what we're solving for. And the first problem is the future value of 5,000, okay, for 10 years. So n is 10, our interest rate is 7, 10 and 7, n and I are in the same units. The PV, what we have right now today, is 5,000 invested in that account. Make sure payment is empty or 0. There's no payment in this problem. And you compute future value, and you should get, I'm going to enter negative 5,000, I'm sorry, because it's money we're putting into the account out of our pocket. And then at the end of 10 years, we'll have $9,835.76. Okay, so I'm going to put that over here, $9,835.76. And that's the first component of this problem. You have 5,000 to invest, and we'll place it today in an account earning 7% per annum interest. If you add, okay, the second part of the problem we're dealing with here, if you add 3,000 to that account at the end of the 5th year, how much will you have on hand at deposit at the end of the 10th year? So if we add 3,000 at the end of the 5th year, how many compounding periods are left, or how many years left? Well, we have year 6, 7, 8, 9, and 10. We have 5 years left. So what we're really just trying to do here is calculate the future value, okay, for 5 periods at 7% interest rate of $3,000 this time. And again, we're going to compute future value. So go ahead and compute future value, and you should get $4,207.66. So if we place $3,000 in an account for 5 years, earning 7%, at the end of the 5 periods, we'll have $4,207.66. But don't forget about our original investment of $5,000. That's still in that account. And right now we're at the end of the 10th year and we're withdrawing all the money. So we withdraw both the $9,835.76, also the $4,207.66. So we actually have a total in that account of $14,043.42. Okay, and that's our answer to number 2. All right, let's look at number 3. Number 3 is actually, is that our two-parter? Yep, that's our two-parter. Number 3 and 4 are the extensions of, or parts of the same question. But number 3, a real estate investment has the following annual cash flows. $45,000 in year 1, $38,000 year 2, $52,000 in year 3, and $320,000 in year 4. If you require a 12% return on your investment, would you be willing to pay $300,000 for this investment? Okay, so this is a net present value problem. So we've identified what the problem is, and we want to calculate the net present value of this investment. And if we get a positive net present value, that means, you know, we're willing to make that investment. We're going to make more than a 12% return on this investment, more than our required return, or our hurdle rate, as it's sometimes called, of 12% in this problem. So when you do net present value, okay, with uneven cash flows, we need to use our cash flow menu. So we're going to be leaving our time value of money menu and entering our cash flow menu for this particular problem, and just entering the cash flows. So I'm going to erase the time value of money menu. While I'm doing this, you could be making sure that your time value or your cash flow menu, go to your cash flow menu first and make sure it's clear so there's nothing left over from any previous problems. Need a bigger eraser, huh? Okay, so this is number 3. And in your cash flow menu, our first cash flow is CF0, CFO, initial cash flow. And what we're going to put in here is negative. Make sure it's a negative, because that's the investment amount, the money going out of our pocket. That's the cost of the investment. It's $300,000. CF1, okay, is positive. That's money coming in, and that's in the amount of $45,000. CF2 is $38,000. CF3 is $52,000. And CF4, that's our $320,000. Now, whenever you calculate an NPV, and that's what we're going to get to, okay, so we're going to be looking for the NPV key in a second here, and computing or calculating NPV. But remember, you need to enter an interest rate every time you calculate an NPV. You need to tell the calculator how to discount those cash flows. So find your interest rate and make sure, or enter 12%. And this could really mess you up, because if you had an interest rate of something other than 12% already in there, you're going to calculate NPV, you're going to get the wrong answer. So this is crucial. Make sure the interest rate that the computer is using to discount these cash flows is 12%. Then go ahead and compute or calculate net present value, and you should get what? Okay, I get 10,000 positive, okay, the sign does matter with NPV. It's positive. Okay, there's a big difference between a negative and a positive in NPV. It's totally different decisions. $10,850.30. So this is a positive NPV investment, and positive means yes, invest. That the present value of the benefits is greater than the initial cost of the investment. And I also know that we made more than a 12% return because the NPV is positive. And that's what the next question gets to. What exactly was our return on this investment? And that's question number 4. And number 4 says, suppose you did pay $300,000 for that investment in the problem 3 above, what would your internal rate of return be? So what is your IRR for this investment? And this is pretty easy on our calculators because we already have the cash flows in the menu, so don't clear anything. Don't clear your cash flows. It's all set up for us already. All we need to do now is compute or calculate IRR, and that will give us our actual return, the internal return on this investment. So if you compute IRR, the calculator might take a second or two because it's crunching numbers and it's finding that rate that makes the NPV equal to 0. And it should show you 13.22%. Okay, so the internal rate of return on this investment, yes, it was higher than 12%. It's actually 13.22%, and that's our internal rate of return. Okay. Well, let's look at question number 5. And question number 5 is also a two-parter. It also includes question number 6, which is half on this page, half on the next page, but we'll get to it. But question number 5 looks like a mortgage balance problem. So you should be thinking about mortgage balances now. Sam borrows $1 million by a mortgage with annual payments. Okay, we're dealing with annual payments here. Usually that's is the monthly or even quarterly, but let's roll with it. Annual payments over 30 years at a rate of 9.75 per annum interest. What are his annual payments? We should know how to do that. What is the remaining balance on his loan after 5 years? And then what is the remaining balance on his loan after 15 years? Okay, good practice here calculating mortgage balances. All right, so let's go back up to our white space. And I'll just roll down there and not try to erase it. And we're working on 5. Mortgage balance primarily here. But first we need to calculate the mortgage payment. And that doesn't hurt. A little more practice on that. Okay, our N is going to be 30. Our interest is 9.75. Our present value is $1 million. And our payment we're going to compute or calculate. So the payment should be, the annual payment should be $103,873.36. Okay, so that's the annual payment on a 30-year mortgage of $1 million at a 9.75% interest rate. Now to calculate the mortgage balance at the end of the 5th year, end of, we're going to use that rule of thumb that we talked about in the notes, that the balance of a mortgage at any point in time is just the present value of the remaining mortgage payments that are due, discounted at the mortgage contract rate, interest rate. So after 5 years, how many more years are due on this 30-year mortgage? Well, we'll have 25 years or 25 more payments left on this mortgage. The interest rate is still 9.75. That's now our discount rate on the remaining mortgage payments. And for PMT, you could leave it in there, or you might change the sign to positive. I'm going to go ahead and change the sign to a positive, but the mortgage payment stays the same, and that's $103,873.36. Make sure future value is still empty or zero. And this time we're going to compute PV, and that will be our mortgage balance. And the PV should be negative $961,283.21. And the reason I changed the sign on the payment is that the mortgage balance due, that's how much we'd owe. It'd be a negative cash flow. It'd be we'd owe $961,283.21. That'd be money out of our pocket to pay off the mortgage at the end of the fifth year. Okay. Well, what about the end, or what about if we pay off the mortgage in 15 years? How many payments would be left if we paid off the mortgage at the end of 15 years on this 30-year mortgage? Well, there'd be 5, right? Okay, so let's just set this up again. So this time, at the end of 15 years, we'd have, oh, I'm sorry, it's a 30-year mortgage. So at the end of 15 years, we'd still have 15 years remaining on this 30-year mortgage. And the interest rate is still 9.75%. The PV we're going to compute, that's going to be our mortgage balance at the end of 15 years. And the payment stay the same at $103,873.36. Future value is still empty or clear. And this time when you calculate PV, you should get what? Negative $801,472.49. That's our mortgage balance at the end of the 15th year, with 15 more payments to go. $801,472.49. Okay, so I think we answered everything in 5. Well, let's take a look at the 6. And we'll have to read this in 2 parts here. Suppose that after 10 years, Sam takes out the loan, and after 10 years that Sam has the loan or takes out the loan or pays off the loan, the mortgage is sold to an investor who requires a 10.5% rate of return on this investment. How much is the investor willing to pay for this loan? Okay, so what we have here is someone's going to buy Sam's loan after 10 years, so there's going to be 20 payments remaining, and the amount of the payment, is still the same, $103,873.36. Now, the person buying this loan wants to have a 10.5% rate of return. So we have to calculate the present value of that cash flow of $103,873.36 for 20 years, the present value at a discount rate of 10.5%. So this is actually a present value of an annuity problem, isn't it? We're just discounting that annuity of $103,873.36 at a 10.5% discount rate for 20 periods. Okay, so a present value of annuity formula, we can use our time value of money menu. And this is now 6. So you want to clear your menu. We're on 1 payment per year. End mode. Okay, N is going to be 20. There's 20 payments remaining. We're going to use a discount rate or required rate of return this time of 10.5%. N and I are in the same units in years, so we're good to go with that. The PV, okay, that's what we're calculating, right? And the payment the cash flow, the annuity to the investor is $103,873.36. Okay, so Sam in this problem, this mortgage problem, he looks at the $103,873.36 as a mortgage payment, money going out of his pocket. But the person or the entity or the whoever's receiving those payments, they view this as an investment, like an annuity, that they're receiving a constant payment of $103,873.36, for 20 payments or 20 years in this case. So compute PV, and that will give you a negative $854,972.15. So if this investor pays $854,972.15 and receives payments of $103,873.36 for 20 years, they'll make exactly a 10.5% return on that investment. That's the internal rate of return of this, fairly simple investment. Okay? Well, that's number 6. Let's go on to number 7 here. Number 7 is going to take a little work, I think. It's one of those problems where it's actually 2 and 1 again. And in number 7, Jennifer is planning her retirement. So these are all those good practical problems. She currently has $6,783 in an IRA account that will return 8% per year as long as she keeps the money on deposit. She will save $2,000 at the end of the year for each year for the next 32 years until she retires into an account that she expects will earn 7% per annum. How much will she have when she retires? Okay, so she's retiring in 32 years. And these are really 2 accounts that she has, or we can think of them as 2 accounts, right? She currently has today $6,783 in this account earning 8%. So what we simply want to do is calculate the future value of a lump sum with that component or that piece. And the second problem within this problem is the future value of an annuity. She's going to save $2,000 at the end of each year for the next 32 years. How much will she have at a 7% rate of return in this account at the end of 32 years when she retires? So what we're going to do is do it in 2 pieces or 2 components and just add the 2 components up at the end. And that's the total amount that she'll have from both of these different investment accounts. Okay, but for the first one, the future value of the lump sum, okay, we have N, I, PV, payments, and future value. And we know we're going to be computing or calculating a future value. And N is 32. Okay, I, or the interest rate in the first problem, is 8%. Okay, N and I are in the same unit, so we're in good shape there, both in years. The PV, and I'm going to enter as a negative because it's money out of her pocket into this account, is $6,783. Make sure payment is empty or clear. And compute future value. Okay, you should get $79,612.63. Okay, so that's what she'll have at the end of 32 years at an 8% return on that original present value of $6,785. That will grow, compound to $79,812.63. Okay, let's keep that on hold. Let me go back up here to get a little bit more space. And we'll do the second piece of this problem. We're still on problem 7. This is part B. And here, again, we can use our time value of money menu, N, I, PV, PMT, and future value. And I'm going to put a box right away in future value because that's what we're solving for. And this is the future value of an annuity component of this problem. And again, the time period is still the same. It's 32 years, so N is 32. Now the interest rate in this account is a little bit different. It was 8% in the first account, but it's 7% in this account. So make sure you get that correct. There's nothing in this account today, so PV is empty, or put 0 in there. But what we're going to do at the end of each year is deposit, so I'll make it a negative, $2,000 per year. How much will we have in 32 years at a 7% interest rate? So go ahead and compute that. And I'll try to find it here. That is positive $220,436.31. So at the end of 32 years, depositing $2,000 per year at a 7% return, Jennifer will have $220,436.31. But remember, from the previous, or the first part of this problem, she's also going to have $79,612.63. So if we add the two pieces together, she'll have a grand total of $300,048.94. So that's $300,048.94. Okay, let's look at number 8. And we have 10 problems total, so we just have 3 more to go. But number 8 is going to be a little work too here. Looks like we're dealing with mortgages again. And Juan has just borrowed $85,000 at 8.25% per annum over 3 years to buy a house. And this time we're dealing with monthly payments. Now suppose Juan wants to retire in 20 years and have his house paid off. How much will he have to add to his monthly payment to pay off his loan in 20 years? So this is something that you could do. Say you're undecided between getting a 30-year or a 15-year or a 20-year mortgage. Well, what you could do is you could always take the longer year mortgage, the 30-year mortgage, and pay it off quicker, and basically turn it into a 20-year or 15-year mortgage yourself. And how we're going to approach this problem is we're just going to calculate the payments for this mortgage based on these terms: 8.25%, $85,000 principal, for both 20 and 30 years, and the difference in the mortgage payment would be the amount that you'd add to the 30-year mortgage payment to pay it off in 20 years. So anything you add to your mortgage payment above what you owe, okay, what your debt services is calculated as, goes to paying off your mortgage balance. And what we're going to do is we're going to calculate an amount that Juan could pay each month, okay, each payment, that would basically convert his 30-year mortgage to a 20-year mortgage. Okay, but the first step, we're going to need to calculate the mortgage payment on the 30-year mortgage. So let's clear that out. And we're dealing with number 8, basically calculating mortgage payments again, which we should be pretty comfortable with at this point. While I'm doing this, you can certainly clear your time value of money menu. And I'm going to put a box right away in payment, because that's what we're going to be searching for, solving for. Make sure future value is empty or clear. Okay, so first for the 30-year mortgage, our N is going to be 360. Our I, okay, our interest rate is 8.25. And I'm going to divide that by 12 because my calculator is set on 12 payments, or 1 payment per year, okay, which I recommend everybody do. The PV, okay, it's given to us directly in the problem, the present value of the mortgage. We're borrowing $85,000. And then go ahead and compute the mortgage payment. And the mortgage payment should be $638.58. So that's simply the monthly mortgage payment on a 30-year mortgage, 8.25% interest rate, monthly payments, and a principal amount of $85,000. Now, what would be the payment on a 20-year mortgage? Okay, on a 20-year mortgage with monthly payments at the same interest rate, okay, we'd have 240 payments, or 20 times 12. again, we're assuming the same interest rate, 8.25% divided by 12. Enter it directly. The mortgage amount is still the same, $85,000. Compute the payment. And the payment for this 20-year mortgage is going to be more because we have fewer payments. And that's $724.26. So, but the question doesn't ask for what's the mortgage payment on a 30-year or 20-year mortgage. It says how much will you have to add to his monthly mortgage payment on his 30-year loan to pay off the loan in 20 years. Well, it's just going to be the difference between the 20-year mortgage payment of $724.26 and $638.58. And that difference is $85.68. So that's the answer to this problem. Remember to always answer the question that the problem is asking. We had to calculate two different numbers, but neither of those numbers were the answers to the problem. The answer to the problem is the difference between those two numbers, or $85.68. So if Juan takes out the 30-year mortgage, okay, and he wants to pay it off in 20 years, what he'll have to do is add $85.68 to each of his monthly mortgage payments, and then at the end of 20 years, his 30-year mortgage will be paid off in full. He'll have a zero balance. So Juan just converted a 30-year mortgage to a 20-year mortgage by himself by just adding $85.68 to each mortgage payment. Now, the only practical implication of this that I might inject into this is that the interest rates are usually not the same for a 30-year and a 20-year mortgage. Usually, the shorter term the mortgage, the lower the interest rate. So if the interest rate for a 30-year mortgage was 8.25, the interest rate on a 20-year mortgage would probably something significantly less than 8.25. So that's the only thing Juan gave up by doing this, was that he's paying at a higher 8.25% interest rate, but he did convert it into a 20-year mortgage. Okay, well, let's move on. And looks like we're on number 9. All right, just 2 more to go. And these two are pretty straightforward, pretty fun, I might even say. Okay, this one I can tell right away. It looks like an MPV problem. So we're probably gonna be dealing with our cash flow menu. And what we have here, Jill invests $15,000 in a parking lot that she expects to have the following annual rents: $1,200 in year 1, $1,300 in year 2, $1,400 in year 3, $1,600 in year 4, and $1,800 in year 5. She expects to sell the lot at the end of the 5th year for $22,000. So at the end of the 5th year, okay, this is really probably the only big trick or little trick in this problem. Our 5th year cash flow is going to be $1,800 plus $22,000, because we got the income and we also have the sale, or the reversion of the property. And it asks, what will her IRR, internal rate of return, be? And if Jill requires a 14% rate of return on her investment, what is the MPV of this investment? So we're just calculating MPV and IRR for these cash flows. To do this, again, the easiest way definitely is going to be using our cash flow menu on our calculator. So go to your cash flow menu, clear your cash flow menu to get rid of the information from the last problem, and enter your cash flows. Okay, CF1, or I'm sorry, CF0, CFO is going to be negative $15,000. Okay, and that has to be a negative. CF1 is going to be 1,200. CF2 is going to be 1,300. CF3 is going to be 1,400. CF4 is 1,600. And CF5, again, The only little trick possibly here, it's going to be the 1,800 plus the 22,000, which is 23,800. Okay? Again, because we got two things going on there. We got the income and also the sale of the parking lot at the end of year 5. Now, let's calculate internal rate of return first, because internal IRR doesn't require anything else to input. Okay, so find your internal rate of return key and compute IRR. And what do you get? Whoop, I didn't do it myself. Okay, so I gotta go. Sorry about this, gang. I gotta go to my cash flow menu. And fortunately, my cash flows are still in here. So I get an internal rate of return of 16.195 or 16.20%. So the internal rate of return on this investment is 16.2%. Well, if Jill requires a 14% rate of return, well, we should do this deal, right? If she only requires 14%, we found out that this investment, its actual rate of return is 16.2%. This is a good deal for Jill. We know that already. But the problem does go on to ask us what would be the NPV at a 14% rate of return on her investment. What we did is we found the rate of return at NPV equals 0. And at NPV equals 0, the rate of return is 16.2%. But what the second half of this problem wants us to do is to enter a discount rate or a hurdle rate of return, required rate of return of 14%. So in your calculator, enter 14% into I, and then calculate NPV. And the NPV should be, I know it's going to be positive, okay? The sign matters with NPV. It's going to be positive. It has to be, because the internal rate of return is higher than the required rate of return. And it's positive $1,306.20. So at a required rate of return or hurdle rate of 16.2%, NPV equals 0. And at a 14% required rate of return, the NPV is positive $1,306.20. So that's our NPV on this investment. And notice, according to both NPV and IRR, this would be a good investment. We'd say invest. We tell Jill to invest in this venture, this property. Okay, the last question. And it's not too bad of a question to end on. Thank goodness. The ABC Corporation is offering a $100,000 lottery to its employees. The winner will receive $10,000 at the end of each year for the next 10 years. How much must ABC place in an account today to meet its obligation if the account pays 7.5% annum? And this is a problem I have in general with lotteries, or little scratch-off competitions, or even the little lottery games at McDonald's that they advertise it as $1 million, but if you read the fine print in any lottery, you usually find that the $1 million might be paid over a very long period of time. And we now know that there's a time value associated with money, and $1 million today is not the same thing as $1 million paid over 10 years or 20 years, as sometimes they are. So this ABC Corporation is marketing or advertising a lottery as a $100,000 lottery, but the winner gets $10,000 at the end of each year for the next 10 years. And what we want to know is how much do we need to place in an account today to meet this obligation of this payment. So what this is basically is a present value of an annuity problem, isn't it? And here's how we're gonna solve it. So we're finally at number 10 here. I'm going to clear out calculator time value of money menu. And we're going to be solving for a PV, so I'm going to put a box right away in PV. And I'm also going to make sure future value is empty or clear. We have a payment of $10,000. We have to pay $10,000 to somebody who wins this lottery a year for 10 years. And we want to know how much do we need to place into an account today, an account earning 7.5% per year. So we have enough money to make this annuity payment of $10,000 per year for the 10 years. And the amount of money we have to deposit or put in the account today is $68,640.81. So in my opinion here, ABC Corporation should be advertising this lottery as a $68,640.81 lottery, not a $100,000 lottery, because that's actually the amount of money that they have to give up or put away to make payments of 10 payments of $10,000 over 10 years. So, well, that's it. Okay, so we're end of problem set number 3. Signing off. Bye now.